So
I think Barry's over there feverishly working on his code based on the stuff that you said. He's like trying to make his water work. So
Yeah, and it's tricky because, of course, on the laptop, it looks fine. It only goes wrong on the device, so I'm having to do some frustrating live updating to see if it works. But I think you've probably showed me the way. Definitely.
yeah, I can point you
Safe
to
enough to show the results live. Let's put it like that.
right. Yeah, I can point you to all this stuff that I've done for it. So
now,
and,
Stephen, I know Corona's got an open beta for desktop and stuff, right? So, is this going to be more of a conversation as people develop more and more desktop apps? You think?
well, the same analysis for the floating point flies. It then depends on whether what it's using to behind the scenes. For if it's trying to emulate the mobile and thus using this rather tight precision, then it would be more of an issue if it was just saying use the desktop part and then you got a much more wide open space and you won't run into these as quickly. You'll eventually run into them if you get really large numbers, but it's this. There's some things that they're not guaranteed to implement, but like infinity and numbers that don't exist. But otherwise, it's basically a floating point number as you would find on the desktop.
And let me ask: is this also something that, like I saw in Barry's comments here in the chat, he's saying that his water shader goes wrong in under 5 minutes. So is this something that, knowing that you could you could instantiate or create something and then kill it and then bring it up, but like kind of cycle through in order to
Well,
compensate?
I think Barry, you're using the time, right? Or you were at some point?
Yeah, well, I mean, I'm passing in a time parameter, but the thing is, I scale it up a lot. That's why it goes wrong so quickly, I think. What I'm trying to do now is finding values that I can modulate, find the modulus a lot lower. What I was doing, because the thing for a water effect, a reasonably natural water effect, I want to have sine and cosine values that don't fall into psych. They're not in the same phase, or they're not the same wavelength a lot. And the problem is I've got like 3 or 4 for X values and 3 or 4 for Y values. I need to find a value where they all do actually end up ultimately in sync within these values. So, and that still looks reasonably random. So that's what I'm doing at the moment. If I can find those values, it should be fine. It should be fine. Knowing the limit was part of the thing, and I honestly didn't realize it was so low for medium precision.
So you, as long as you know that you can just bump it right up against the edge of something and not go over that, then everything would be fine.
Yeah, yeah. It's like you were saying about the lowest common denominator. I mean, all I will do from now on is I just will never assume anything higher than a medium precision float. And then knowing that, you can plan accordingly. It's just I didn't do that, so sort of retrofitting it now is, and trying to make it look nice is a little bit trickier. Plus, I keep finding more and more sine and cosine values scaled up in my code. The shape is quite long.
Yeah, the sine is at least convenient in that it's periodic, so you can do the mod. You can cut the values down to a range, and you can use some modular arithmetic and all this stuff. But with some functions, it's what do you do? There's no repeating pattern or whatever to take advantage of. And this is why I mentioned before that it would be nice to be able to reset the time, so that it isn't in the area where you have to think about this constantly, where you might be able to, between your levels, reset it or whatever.
Yeah, but then, I mean, this is when we talked about this earlier. This was one of the first things that occurred to me. So I'm passing it in as a parameter, and my time parameter does wrap. So it just means sort of every 15 minutes in my game, the water jerks because I'm looping the value. I haven't found a decent wrapping point. But yeah, I mean, the time value just going up continuously is going to probably cause a problem with a lot of things. Okay, it may take 20 hours or something, and we hope no one is that obsessed. But it's definitely something to look at.
Yeah, well, I mean, the 20 hours thing that would just be if you were only using the time, but it could happen faster if you're scaling it. So,
Mm-hmm.
so it's just good to keep this in mind for whatever situation might come up. And, that's what I have on numbers. I could move it to the math effects at this point, if there's no other questions.
I got a quick question.
Okay.
Can you calculate logarithms in Shader?
Yep. Yeah, there's log base 2, and I think there's at least log base 2. There might be log 10. I don't. Yeah, there's natural log, and then log base 2.
Okay. Just a random question.
Okay.
Yeah, nothing coming out of that. Feel free to proceed.
Okay.
Half-formed thought, sorry.
Just a random, hey, can you microwave popcorn with this thing?
That was my next question. It's not the night show, so I can't use the appropriate words to describe that comment.
Yeah.
But it starts with smart. Let me just say that. Okay, go ahead, Steven. Sorry.
So I'm going to discuss this. Are you seeing this?
Roger.
Okay, so this is a laser effect I've been playing around with. And under the hood, this is a rect that is anchored at one of its side points and spinning around. And there's a few things going on. You can see the wave pattern along the boundary. I don't know if it shows up, but it's especially bright in the center, and there's a little bit of noise applied to the beam in the center, so there's white leaking off into the blue. Is that visible, or?
Yeah,
no?
Yeah, we can see that.
All right. And okay, so I'm using a noise function from Shader Toy called IQ noise. I guess it's the guy's initials. And I had to tame this because the numbers were in 43,758, and it was doing what I'd said before. That's very close to the limit, even with high precision. That kind of gets to the boundaries. So I just moved the decimal point over, and I'm using that to calculate the noise both on the boundary and inside. The noise, and a recap, noise is coherent randomness. So it's a number that you take two nearby values, the noise will be close to it, the same value. And it's reproducible, so if you pass in the same inputs, you get the same noise value back. And it's between -1 and 1. So I can use it to displace up and down.